Hey everyone, welcome to my channel. Today we are going to explore SQL by running advanced queries on a bank database. Whether you are new and want to learn the basics, or you're experienced and want to improve your skills, this video is for you. The database we will be working with contains two tables, bank and fraud. This is a database for internal use within a bank. One table contains general customer data, while the other contains specific infractions that have occurred involving some of these customers. Of course, I have included links in the description below where you can download both tables that we will be working with today. To begin showing you what each of these tables is about, I'm going to run some very basic SQL queries. And for that, I'm going to start with the use statement. The use statement in SQL is used to select a specific database to perform operations. It sets the current database context, which in this case is the bank database. Now, let's see how many records exist in the bank table. So let's start with select, which indicates that we want to retrieve data. Now let's apply the function that counts all rows in a table, which is count. With an asterisk between parentheses, which indicates all columns. This represents all columns, and when used with count, it counts every row regardless of the value in any particular column. And then the keyword from, which specifies the table from which we want to retrieve the data, which in this case is bank. And let's execute our query. So we have 11,388 records. Now let's take quickly a look at the fraud table. 15 records. Now let's display the entire content of the bank table. For that, again, select. Let's retrieve all columns and rows from bank. So, as I said, this database was designed to store information about clients of a bank. It includes various attributes that can be used to analyze customers' financial status and their interaction with the bank. For example, the age of the client, the type of job, marital status, education level, contact, which means the type of communication used for contacting the client, the day of the month when the client was last contact, the duration of the communication, deposit, whether the client subscribed to a term deposit, so yes or no, the outcome of the previous marketing campaign, which can be success, failure. In this case we have unknown, but there might be failure or success as the value as well. So in this data, we will base our SQL queries. Let's take a quick look at fraud table. And this table provides information about different incidents that have taken place with the date when the incident occurred, description, the type of or category of the incident, the ID, which is very important to link one table with the other. So this database will enable us to perform interesting queries and gain valuable insights into our data. Alright, so in this exercise we should write an SQL query that help us understand which job types have the most customers making deposits. As you see in this column, we have all the professions and we will be looking at how to group our data by job type, then count the number of customers with successful deposits, and finally order these results to see which jobs are leading. So let's start by breaking down the first part of our query. Here we are selecting the job column from our table and using the count function to count the number of rows for each job type. Now we'll set an alias for that count. Num customers, so that we can label the results so we can easily understand how many customers belong to each job category. Now we will make the reference to the table from where we are getting the data, which is bank. Now we have to focus on filtering our data to include only those customers who have made a deposit. And for that we will make use of the where clause. That makes reference to the deposit column. And we will base our filter on the word yes. So far our query is selecting the job types and counting the number of customers from the bank table who have made a deposit. Thanks to the where deposit equal to yes, is that we set our filter in order to include those who made a deposit. So this setup allows us to focus specifically on customers with successful deposits, giving us a clearer picture of how many depositors belong to each job category. Now we have to group our filtered data by the job column. How we do that? With a group by clause. makes reference to job column. So grouping by job means that we are organizing our results so that all customers with the same job are grouped together. This is very important for counting the number of depositors within each job category. And finally, sort by the highest number of the counter first. So we are finally sorting the result in descending order. And here the num customer is the alias we created earlier here in this select. And that was the sense of creating that alias, because it makes it easier to reference the count directly in our order by clause. So let's see what we get as a result. So here we have the output that shows the count of customers who made deposits grouped by their job titles. Alright, so in simple terms, here we should find the customers whose balance is more than 1000 and who don't have a loan. So select and here we should focus on the attributes of those customers that the exercise is asking to retrieve: age, job, marital status, just education, right? Yeah. From. And now once we have the reference to the table we are going to get the information, we should filter the data based on two conditions. Balance should be greater than 1000, and loan will be equal to no. So in this way we will be selecting only those records from the database where both conditions are true. So loan, it's great. So let's execute this query. Alright, so we should get the month with the highest number of deposits. So we will start by selecting the column in the table, name month, this one. So that column contains the data presenting the month in which deposits were made. So there we apply the count operation on all rows in the table. From name of the table. And now we will apply a filter condition with where that specify a condition that filters rows from the table based on a certain criteria, and the condition will be where deposit is equal to yes. So this clause selects only those rows from the table where the value in the deposit column is yes. This means only data related to deposits will be considered. And then we will tell the database to organize the data into groups based on the values in the month column. So group by. Order by. To order our results in descending order. And limit 1. Limit 1 in order to get only the first row that matches the query condition. Alright, so let's execute this. So May is the month with the highest number of deposits. Alright, so here we have to analyze how marital status affects the likelihood of customers making a deposit. And to achieve this, we should run an SQL query that organizes the customer data by marital status. For each marital status category, we count the total number of customers and those who made a deposit. And then we compute the deposit success rate as the proportion of customers who made a deposit within each category. So to understand it better, let's move on to the code. So we start by specifying that we want to retrieve the marital column from the database. And then we count the total number of records or rows in each group of customers who share the same marital status. So this count function counts all rows in each group. And now we have to count the number of customers who have made a deposit. And for that we will have to use a conditional. So again we apply the count function. And the conditional expression will be a case statement. And this case statement will check each row to see if the deposit column has the value yes, and if it does, the expression returns 1 for that row, and if not, it returns null, which is not counted by the count function. The alias will be num deposit. Remember, the alias assigns an alias to the result of the count function. This column num deposits will represent the number of customers who made a deposit, and the count function will count the number of times the expression returns 1, and this will effectively count the number of rows where deposit is equal to yes. So now for the purpose of this exercise, the next line will be about calculating the percentage of customers who made a deposit within each marital status group. And this is very important because it determines the success rate of deposits for each marital status. Here we can copy here, same. Then we multiply it by 100. And we divide it by the number of counts. So first we count the number of customers who made a deposit, like we did previously, and then we divide the number of those customers by the total number of customers in this count, and then we multiply by 100 to convert the result into a percentage. So this part gives the number of customers who made a deposit. This part, this count, gives the total number of customers in the group, and then we assign it to success rate. As name of the column, we will display the result. Where the database comes from, then group by, so here we gather all the rows in the same marital status into groups. So we organize the data by marital status so that calculation can be performed for each marital status group independently. And finally, we should organize the rows so that the marital status groups with the highest deposit success rate are listed first, making it easier to identify which marital status are more likely to result in deposits. So for sorting them, we simply use the clause or order by this one, success rate. Alright, so let's execute this query. And here is the result. In the success rate column, we get the percentage, and it looks correct. So in this SQL query, we should calculate the average duration of phone calls for each job category. Now for that, we will have to use the duration column, which is this one, which supposedly records the length of phone calls in seconds. Yeah, it is, could be in seconds. And then we will have to filter out job categories where the average call duration is 100 seconds or less, according to the exercise. This could help in identifying job categories where with longer average call durations. Calls in a bank could be related to many activities performed by banks, telemarketing or customer service. These activities might include promotional offers, service, customer support. So in the first part of our statement, we will want to retrieve the job column from our table. So select, and then we will calculate the average value of the duration column for each job category. And for that, we will apply the avg function that is responsible of calculating the average of a value, and then alias, now we will indicate the table from which we get the data, bank. And now we will group the rows in the output result set by the values in the job column. So for that, group by job. And here comes the tricky part, because we have to filter the results of a group by query already based on a condition in order to complete this part of the exercise, because we have to focus on call durations greater than 100 seconds, and for that we will apply the clause having. Greater than 100 seconds, and let's see our result. And that's the result according to the job column. So this clause is similar to the where clause, but it's used for conditions on aggregate function, because we are applying a condition to the groups already created here. So in this query, we should even identify the row with the longest call duration, but with the particularity that we should apply the row number window function. The row number function assigns a unique sequential number to each row in the result set according to the specified ordering. The numbering starts from 1 for the first row and increments by 1 for each subsequent row. This can be useful for tasks such as ranking or paginations, where you need to identify or manipulate individual rows based on their position within the result set. So as the exercise asks us to select all columns for this row, we will select all columns of the table from a subquery again. Here the subquery, select so this part, starting from row number, generates a row number for each row ordered by the duration column in descending order, and the row number function assigns a unique integer to each row based on the specific order. The over clause, this one, defines the window over which the function operates, and in this case it's the entire result set of the subquery ordered by the duration column in descending order. So the subquery returns all the columns from the bank table along with an additional column named number row, which contains the row numbers assigned to each row based on the duration in descending order. And outside this subquery, we'll write the where clause, which will filter the rows based on the condition that we are going to write. Now, it's the name of the alias, this one, equal to 1. And this condition selects only those rows where the value of the row we generate here is equal to 1. So since the row number function assigns a unique sequential number to each row, therefore the row with the highest duration will be assigned to the row number 1. So let's see if it works. And here we get this one, almost 4,000 seconds, means it's almost 1 hour. The durations, they took a lot. So that's the result applying the row number window function. So this query is about analyzing marketing campaign data. We'll calculate the average number of days since the last contact for customers. If we look at our table, P outcome represents the result of the previous marketing campaign for each client. It indicates the outcome of the last time the client was contacted. Where we have so far unknown value, but if we query our whole table, we will notice that there might be other type of results. For example, here it says success. Failure, success, unknown. And here P days represents the number of days that have passed since the last contact from a previous campaign until the current moment. The value -1 indicates that the client was not contacted. But for example, here we have 91 days, or so those are the columns that we should take into account in order to make our exercise, which will begin by selecting our P outcome column. Remember, P outcome column represents the result of the previous marketing campaign. And then we will calculate the average number of days. Since the last contact. As alias. PFG days. From bank. Where P days is different from -1. It's different from -1. So remember, P days is the column that indicates the number of days since the last contact with the client. We will have to exclude -1 because that -1 indicates that the client was not previously contacted or there is not available information. And last but not least, we will organize the data by P outcome column with the clause group by. Which allows the calculation of the average number of days since the last contact for each campaign outcome. So here we have the average number of days. For example, for the last campaign, or since the last contact, were 4 cases where the previous campaign outcome was failure. This means that on average, clients with previous campaign result of failure were contacted again after about 237 days from their last contact. And for a success outcome, the average number of days since the last contact is approximately 161. So these results provide the information we were looking for. So the query we are going to write in this exercise will count the successful deposits that occurred after a marketing contact, which is represented by this column. So the query will first calculate the total number of contacts and successful deposits for each month. Deposits are represented by this column, month, here. Then we will compute the success rate as the percentage of successful deposits. And finally, it will filter to show only the month where the success rate is above 50%. Alright, so we will start by creating a common table expression. So this common table expression will be useful to preprocess some values from our bank database. This will help simplify our main query, making it easier to read and understand while also improving the performance. And by isolating some calculation within this common table expression, the main query becomes simpler and more readable. It's like breaking down the query into different parts, which make it easier to understand the overall logic and purpose of the query. So once inside the common table expression, we will group the data by month. So then we count the total number of contacts and also count how many of those contacts ended up in a successful deposit. Alright, so in this line we use a case statement to check if the deposit column has the value yes. If it does, it returns 1. Otherwise, it returns null. And the count function then counts how many times the condition is true, giving us the total number of successful deposits. And we will name this count So then we will specify that we are selecting the data from our bank table, and then we will use the group by clause. Just to organize the data by each month. Which means that any aggregate function like count will be calculated separately for each month. allowing us to see monthly totals and statistics. Alright, so now let's move on to the final part of our query, which will be done outside the common table expression we did here. So we will select the month, total contacts, and successful deposits from our pre-processed data from the common table expression. And we calculate the success rate, which is the percentage of successful deposits out of the total contacts for each month. So let's do that calculation. By total contacts. And name it success rate. And as the last part of our query, we will select the data from our common table expression instead of our main table of our database, which is bank. In this case, the from clause will point to monthly stats. And the last part of the exercise is to filter the month where the success rate of deposits is greater than 50%. So by doing so, we will write having success rate greater than 50. And why we use having? Remember, the having clause is similar to where, but it's used to filter groups after the group by clause. And in this case, the group by clause has been already applied here. So here we are filtering the results to show only the month where the success rate is greater than 50%. So it's important to note that the most heavy part of the logic of our query is done within the common table expression, which calculates the total number of contacts and successful deposits for each month. And when we use our common table expression in our final select statement, we can easily calculate additional metrics like the success rate without having to recompute these values again. This makes our query a lot more efficient and easier to read. So let's execute our query. So this is the result of our query. We have total contacts, successful deposits, and success rates in percentage. So in this exercise, we have to combine the bank and fraud table to see the records that have a matching ID in the bank table and an infraction ID in the fraud table. Let's take a look at the fraud table. So many times we have to analyze data that is spread across multiple tables, which is similar to the exercise that we have to do right now, where we have to analyze which customers in our bank table have corresponding infractions recorded in the fraud table. And to achieve this, we need to combine these two tables to see the records, where ID from the bank table matches the customer ID from the fraud table. This is a common task when working with relational databases, as it allows us to gather related data from different tables into a single unified result. So let's start by selecting all columns from both tables. Now let's specify our primary table, which is bank. Inner join fraud. Here we are telling SQL to join the fraud table with the bank table. An inner join combines rows from both tables where the join condition is met. On which specifies the condition for the inner joins. So by using the on clause, we ensure that only rows with matching values are combined in the result set. And the important part of our join condition is in bank TID, bank dot ID is equal to customer ID. Bank, not band. Bank.id is equal to customers ID. So let's see what we get. So we are getting all columns from both the bank and fraud tables, but only those records where there is a match between bank.id and customers ID. So by using this inner join, we can easily see which customers from the bank table have infractions in the fraud table. So we continue with exercises involving our two tables, bank and fraud. Our goal now is to identify customers who have suspicious transactions and calculate their total balance. So we will join both tables, then filter for suspicious transaction, and then calculate the total balance for each affected customer. So let's start by breaking down the first line of our query. So it is select. Here we will start by selecting the ID of each customer from the bank table, which will have a C alias. This identifier will help us differentiate each customer in our results. Then we will calculate the total balance for each customer by summing up their balance entries. So this function sum adds up all values in the balance column for each customer. We then label this calculated value as total balance. Then we specify the table we are working with, which in this case is bank, and then we add an alias C by adding C right after the table name. We are creating an alias for it. This alias makes our query cleaner and easier to read. And now let's move on to the join operation. So in this part of the exercise we are joining the fraud table, which will have an alias I, and now we will specify the condition for this join with the clause on, and the condition is that we have to match records where the ID from the bank table is equal to the customer ID from the fraud table. So that we link each customer's bank records with their corresponding fraud records, allowing us to analyze the relationships between their account activities. And now let's move on to the part of the query where we filter our join results to include only those records where the infraction type in the fraud table is equal to suspicious transaction. For that we apply the where clause. So we invoke the alias we defined to the fraud table, and then infraction type equal to suspicious transaction. So by applying this filter, we are narrowing down our dataset to focus just on customers who have been involved in suspicious transaction. And now finally we have to make sure that the sum function that we used earlier here calculates the total balance for each unique customer rather than summing up balance across all customers. So in this way we get a total balance for each customer who has a suspicious transaction. And for that we will have to group the results by the customer ID from the bank table, which has the C alias. So group by well, let's try our query. And here's the result. Let's check quickly if, for example, the ID number 5 has that balance. And yeah, alright. In this exercise we have to write an SQL query to identify customers who have not committed any infraction. So we aim to find all customers who have a clean record, meaning by this there are no infraction associated with them. So our goal is basically to extract information from the bank table for customers who do not appear in the fraud table. We will see this in our code. So we'll start by select, and we will get all columns from the bank table, which will have a C alias asterisk to get all columns. Now let's make the reference to the bank table with the alias. Next, we will be using the left join clause to combine data from the tables bank and fraud. So why left join here? Because it includes all records from the bank table, regardless of whether there is a matching record in the fraud table. So the utility of the left join clause in our query is to help us identify customers in the bank table who don't have any corresponding record in the fraud table. This is particularly useful for isolating customers without any fraud incident, which enables us to analyze on clean records specifically. And now after the left join, we will use the where clause to filter results. And our filter will be based on the records where there is no matching entry in the fraud table. So for that we will just copy this reference to the IDs from the fraud table is not. So in other words, this condition helps us identify all customers in the bank table who don't have any corresponding fraud records. So you might be wondering why we are using left join instead of inner join. The difference is that inner join would return customers who have a matching records in both bank and fraud tables. This means we would only get customers who have been involved in some sort of fraud. But in this exercise, our goal is to identify customers who don't have any fraud record. That's where the left join helps us, because it returns all customers from the bank table, only from the bank table, including those with and without matching entries in the fraud table. So let's try our query. And that's our result. For example, I remember the customer with the ID number 5 appeared in the infraction table, for example, yeah, number 5, and he's not here in this result set. Also 34, it's not there. So it means our query is working correctly. So this query is about finding the most recent infraction for each customer in our bank table. So we should link each customer with their infractions, and then through a subquery, it will be possible to get the latest incident for each customer. So let's begin by selecting all the columns from both the bank table and the fraud table. With their respective alias. By doing this, we make sure that we get a good view of each customer along with their infraction details. Now let's make the reference to the table we will be working with, which is bank, and with its alias, so that we can reference this table more easily throughout our query. And moving on to the next part of our query, we will be using the join clause in order to link the two tables based on a common column. Which is the ID column. This means we are combining rows from both tables where the customer ID in the bank matches the customer ID in the fraud table. So by this way, we get a complete view of each customer and their infractions. And now we have to focus on the date of the infractions in order to order them from the most recent infraction to the oldest, and for that we will have to use a subquery to filter the results. So here we set up a condition where we will be comparing the date of each infraction. Here we will be comparing the date of each infraction with a specific value. And what this subquery is going to handle is to find the maximum date for each customer's infraction in the fraud table, so that then we can compare this maximum date with the date of each individual infraction in our main query. So let's see how it works in our code. Here we are defining another alias for this scope. Our alias for the fraud table, but in a different scope. So with this function we are extracting the maximum date from the fraud table, and by isolating this maximum date associated with each customer's infraction, we are identifying the most recent infraction for every individual. So let's make now the reference to the fraud table. And now let's focus on the condition within our subquery. Is equal to c.id. So this condition ensures that we are obtaining data related to the same customer across both tables. And at the end of our query, we'll focus on the line that instructs the database to sort the results based on the date column from the fraud table. The fraud table is alias I date column, and the desk keyword will order the dates from the newest to the older. And so let's try now our query. And as you see,